Lights, camera, action. Actually, there's a good effect of this, which I will be discussing it here. Dream to explain engineering in the most simplest way as much as possible I can. I've come across many people who say that I have that ability to explain. I have good mindset. I am able to explain myself. To be honest, teaching to a class of 20 plus in 1 hour is a bit daunting for me. So I thought that I start with small things at first. Not that doing this is small. I don't feel it's small at all. As a matter of fact, it took me a lot of guts, a lot of energy to come up with this. So yeah, I'm gonna be explaining what is engineering and the different sub branches of engineering, which you can all Google it. It's available. But I'll explain the parameters that we consider in engineering. What are the basics that comes in the engineering? It's something that you learn in university. That's true. But when you come into the practical world, how you correlate with it, how you correlate your theory with your practical, that requires a different set of skill, and I wanted to bridge that. So I'm like the bridge. Hey, nice though, I just came up with a bridge. Good. So let us start with engineering. So I work as a structural engineer, and I'll be explaining some basic concept that all will also be working in different ideas and how we can do it. These concepts can also be applied in mechanical engineering, in aerospace engineering. First year is always in engineering. This a very amazing thing that in engineering, first year is always common for every one of us. Then we begin to specialize in our field. So for me, my first core branch was civil engineer, and then I specialized into structural engineer because I was always passionate about designing and how the structure work. There's also mechanical engineer, you've got your chemical engineer, you have your aerospace engineer, you have computers engineering, you have electronics engineering, the list goes on. And yeah, I'll try to compress as much as possible, but yeah, we'll just go with the basics of civil and mechanical, structural, and yeah, aerospace as well. Try to compress the first principles, as they say. So yeah, I guess this has something to play with it. I'll explain to you all. Ouch. What is engineering? Engineering is defined as a way for concept to become a reality. In a way, we make it into a reality. Clients, people imagine, and we make sure that it is a possibility. So yeah, and the good thing about this is this engineering branch of mine, civil, structural, aerospace, mechanical, so on and so, it's more into these sides. So if anyone's that passionate about it, yeah, this is a good step for you to know if you are considering it. You know, I want to be in civil engineer, I want to be in as a construction engineer, if I want to be a structural engineer, if I want to be a mechanical engineer, or if I want to be an aerospace engineer. All of these are great branches. All fields is great. What I'm trying to do is I'm going to try to make it an open area for these sub branches, so that anyone can, who has a passion, who has a keen interest in pursuing engineering, can know what's to come in their first uni itself. So yeah, I'm excited about it. I do hope that I'll be able to make it as clear and concise as possible. But of course, if you have any questions, I know you can't ask me right now, but a Q&A will be done, in which it will be for anonymous. No one's name, no one's contact informations, nothing will be shared or come into me as well. It'll be completely anonymous. And two things are important for me. Number one, I'm not going to judge you. I don't have the time. A, and B, I'm not a god. I'm a human being. So even I do make mistakes. Even I have some questions that may sound ridiculous, but sometimes that question can lead to another question that can become a good question. So question that's ridiculous to you might be a good question to the whole world. So just keep an open mind and don't never doubt that this person is going to judge me. Oh, I don't know about, I can't speak for everyone else. I can only speak for myself, so I'm not a judgment person. So that's one thing. And the other thing is, I guess the only thing is that if you're not gonna not ask me questions, then I'm just gonna keep on continuing forward. And in the future, if there's something comes, like some element or some kind of a technical term comes, and then if you didn't ask me at that time, but now you are having that question, then it's a bit of an issue, because why didn't you ask me at that time itself? So keep an open mind, ask me questions. I'm not here to judge. I am here to create an environment where everyone can learn. For us in mechanical, structural, civil, let's call our branches, for what name would you consider this? I would say like more into creation. I would say creation engineering. Creation engineering consists of civil, mechanical, aerospace, what else, structural, which is a sub branch, but yeah, that can also be counted. So all of these comes into creation, like construction mechanical, let's call that. I think that's a good terminology to use. So yeah, copyright that. So in construction engineering, us need to understand what are the forces coming along. Good question. What is a force? A force is defined as you apply this at an acceleration. So my hand is a mass and I'm giving it the acceleration. So that this thrust, this is called force. I have given a force, which is my mass, into the accelerations. Force, we'll also be using the SI system, which is the Système of Internationale. It's a good way for anyone to understand what is what. My technique is, if I want to understand something, I always go with what is the SI unit of that terminology. Some terminologies might not have an SI unit, can't be bothered, can't be done anything. But some of them have it, so you can correlate with that to know what is what. So the SI unit of force is kilonewton. What force is going to do is, we will be using that force to understand the action effects from that force. Something that you apply obviously produces some kind of a resultant. Force gives a resultant force. So what are those resultant forces? As a structural engineer, civil, or even a mechanical engineer, or I think in aerospace, sometimes aerospace actually, we need to understand whether our materials, whatever we design, either a house, structure, mechanical, trains, trams, bridges, anything, roadways, even the shuttle that goes up in the space, we need to make sure whether it is able to withstand the environmental effects that come into play, because those environmental effects produces the action effects on those. So we need to understand whether our materials or instruments or constructions are durable, are able to withstand it. So what are those action effects that comes into play? There are many. So let's get started with the action effects. Actually, I should put this down. We'll have an explanation with that one. Creation engineering, the action effects that come into play are bending moment, shear force, torsion, and there are more, but right now in my case, for me, I'm just being worked on bending moment, shear force, and torsion. Torsion is more in a more detailed way. We'll come back to that later on. But for today, we're going to explain what are these effects. Torsion has some relation in mechanical, civil, structural, not much in aerospace because there is no torque working about it. So torsion can be neglected, but for my case, hey, fun fact, you get to know torsion. So what are these things? Why do we consider this? Oh, and very important thing, this is a very critical aspect of any force that comes. When something that falls onto a body, this thing produces some kind of a curved. How much this curved is being allowed for this area. So I'm gonna use a red pen just to make it a clarity. So this much, this phenomenon is called deflection. All right. So let us start with explaining what goes in my goes in all aspects, to be honest. Let's go with that one. The action effect. Everyone can hear me, right? I mean, if not, just let me know in the feedback, or I'm open for feedback as well, just to know if anything goes wrong or anything, or if my handwriting is not good, just let me know. The action effect. These action effects consist of the following things. Bending moment, shear force. So, what are these phenomena? What is action effect? What is an action effect? Why is it relevant to me or to any engineer that comes into play? Action effect is my resultant force. And my force is my applied force. So this causes this. What is a shear force? Shear force meaning like you applied something, and because of that it begins to snap it out from the joint like a scratching. So let's take an example of a beam. That's my beam. That's my force that's being applied to it. This being is now under the effects, under the action effect of shearing. Caused by the applied force. When it becomes very high, there is a likely chance that it will break, it will snap. This has now come to a failure. My job as a structural engineer or in any part of engineering is to prevent this. How do I prevent this? I can prevent this by two ways. Way number one is I can better increase the stress grade of this member. So I can either increase stress grade, the resistivity of that, or I can increase the size of it. These two are the only possibilities I can do it, or there's one more, I can redistribute this force, reduce it, but that's very unlikely to happen because it's going to be there, and to be honest, nobody wants to come into it. So yeah, we're gonna get this going with. Let's get started with our next process. So as I explained before, the shearing is being caused by the tendency of it to snap up. Now, because there's a high amount of force, the SI unit of a shear force is kilonewton. It's a simple way to understand what is happening. Now, how do I prevent this? You can't prevent it. It's inevitable. What I can do is I can increase its grade or the dimensions of that member. This has failed, so I'll increase it more size. Why is that? Because the area where the load is falling onto it, it's now having a higher resistivity to prevent it. If something is like this and I put a force onto it, it will snap because it doesn't have the contact area. But if I have something bigger, it has a large contact area. So that means is that the force that's being applied has now more area for it to be resisted, more members for it to resist it. All these will now be acting against it. So there will be a resisting that going upwards, more for it to stop it from snapping off. So that's shear force. I'll explain with a practicality example. Now we come to bending moment or Some people simply call it as a moment. This is also resultant effect or force. What is a bending moment? People get confused, like, what is a bending moment? What is a moment in reality? Bending moment is, I have a beam. I am right now applying a force. This beam is fixed by some support over here. Let's make this very easy. So this is supported here. The beam, this is stiff. The beam will now begin to bend. From its original position. This is causing it to bend. It's making it to fall down. So right now this is a very stiff members, but if suppose it was a less dimensional area, so there would be a likely force that it's gonna bend. This is causing it to bend downwards. It's going downwards. The beam would need to have a resistant force to bring it back into the original position. So the phenomena is defined as the ability for it to return back to an original position is known as a bending moment. The higher the bending moment, the more likelihood there is a chance for it to fail. So what is its SI unit? Technical terminology, technical definition of a bending moment is the distance of the applied force at a fulcrum arm to the reference point is known as a bending moment. Very simple to remember this. People get confused. There's nothing wrong in that. Some people will get confused, so that's all right to it, and there's nothing wrong into it. I just feel sorry for those people who judge, like, oh, how can you ask this question? Sorry, I feel sorry for that person. Suppose this is fixed at here. That's my force, which was my kilonewton, as I said it, and this is my reference point. So the reference point here to here is L, which is usually given in meter. So bending moment is force into length, which gives my SI unit as kilonewton meter. I use the SI unit system to understand different terminology. It's very easy for me. I find it quite relevant. So, are we clear? I mean, obviously, if you have any questions, do feel free to ask. Now, my question to all of you is, why do you call it a moment? I mean, isn't that like a rotation effect? Can't you just call it simply as rotation? Just say rotation, rotate force, something like that. But why do we call it bending moment? There's a reason to that. It is called a moment because this bending that, let me show this with a red pen. This bending is being caused at this point. This point, it begins to bend. This is it was at this moment that it begins to bend. Hence, that's why it's called a moment. It's more like a momentum rotation. So now I will be showing with a practicality on how it affects. This is a beam. This beam is now having a force. It's been fixed at first end, so there's this and this coming into effect. Okay, so a force is being applied over here. It's going downwards. This beam needs to come back to its original position. There is also another important aspect of bending moment. Two terms comes into effect which you should know. It's quite good. It's actually relevant to it. What are those two terms? Moment creates two things: sagging and hogging. These are the effects. Now, what are sagging and hogging? A beam is there. It's beginning to bend downwards because of the force. This phenomena is called a sagging. It's going downwards. A beam is right now at a stand position. The beam is being bent by a force from downwards and it's beginning to, I'll show it like this. It's going to bend upwards. This is called as hogging. So, sagging, wait, let me just give this more simplified way. This is my original beam. It's being fixed at both the ends. This causes a sagging which goes like this. A positive bending moment. This is called as positive. That was my original position. This is my original, and this is my resultant. It's very easy to remember this. Sagging, I'm smiling, I'm positive. It's not a phenomenon to be considered when we get to forces. So I know you all will be thinking, hey, smiling is a good thing, but it's not. It shouldn't happen. It's just a way to remember. Hogging. This is my reference point. This is being bent upwards. It's called negative. This is the resultant. Force being applied top to bottom. Force is being applied from bottom to top. There's a good thing. This practicality has occurred in concrete bridges to be precise. If you walk across bridge, you'll notice that bridge are hogged up a bit. They have actually been hogged up a bit. The reason why they do it, because concrete has a tendency to change as per temperature, moisture, the loads that are being applied to. So in time, what happens is, this is the slowly it begins to hogged up. Sorry, this is hogging. Slowly it begins to sag downwards. That's why they never put a bridge straight, because what happens 10 years afterwards, it'll be sag like this. You don't want to go to a bridge that's being curved. There's a tendency for it to fade. So it's going to come like this. So in order to prevent this from happening, they hog the bridge a bit so that in time it comes to when they do their services. So yes, this all comes under bending moment. So yeah, if you have any questions till now, just keep note and just in Q&A you can pop up your questions. I'm more than happy to answer each as much as best to my knowledge. I will answer it. If not, I will definitely try to find the answer to it. Now, these are the phenomena that are being acting on it. What are the other things that we consider? We consider the supports. These supports, well, if you look outside, even at your house or anywhere, in your house itself, you'll notice that everything has some kind, is being supported by something, but those supports can be correlated into three major aspects. What are those three major aspects? What are those three major supports? Hinge, or pin support. It's usually shown like as in this way. So if you see something like this way in my classes, you will notice it's a hinge or a pin support. Actually, you know what, I might as well show this with a different color because I think it will be more easy to understand what is what. That's more easy. I'm going to break from here so that it's more easy to understand. Roller support. This is shown like this. It's been hinged over here. You have your rollers at the bottom. This is usually done in cranes. You'll notice this a lot in cranes and everywhere. Finally, this is more relevant to all the structures and every civil and mechanical. Let me know if my handwriting is all good, otherwise I can find different ways to improve it. But I think it should be readable. Fix. Now, why are these relevant to us? What does it? These are relevant to us because all of these supports are giving me a reaction to the force that's being applied onto it. I'm applying something over here. This something is gonna happen over here, right? Because if let's say I'm something like this, I'm giving something, even though the impact is coming here, something is gonna happen. No matter how stiff I am, I'm gonna feel something here as well, because this is my support. It's the reaction that's coming into play. I mean, if nothing was here, this thing, my arm would just fall down. I mean, in a way, it's right now, something is here itself, the support is there. So all of these forces are gonna fall into it. And because of this, let me know if I'm audible or not. Otherwise I can intensify my volume. So there is going to be some kind of reactions at these points. These reactions will provide degree of freedom. Freedom. Meaning, what can they stop and what are they free to move about? These points are they're called, in simple terminology I would say points, but in technical terminology they are called as nodes. The reason why I'm being so simplified here, because when we hear engineering some aspect, right, we get a bit repetition. It's difficult. It is difficult in, well, to be honest, every field is difficult. Nothing is easy. It's how you perceived it, how you are able to make it more fun, make it more livable, make it more interesting. So I'm giving you an outlook about my work as a structural engineer, civil, mechanical, or in any aspect of engineering. So I do hope you can take a screenshot if you want, just to for your reference, just to give you the post. I think we should stop here for now, but if you don't, I might as well explain what is degree of freedom. Might as well finish it strong. Actually, you know what? I think we should continue, because this is another aspect, and I don't want to rush things. We all need to have our breaks sometimes. I would love to, but I think understanding, you'll obviously have some questions by now, everything. So tomorrow I'll get into degree of freedom and how shear force bending moment act. It's good that if you can go through by yourself, like, just seeing a YouTube video or Google it, you can have a look and see if you have any questions. But yeah, Q&A is now ready and it's open. Just give your questions, whatever questions you have till now. If everything was clear, that it's good. I'm actually having some questions, but it's great that if you don't, but if you do, I'm happy to answer it. It's all going to be anonymous questions, so there would be nothing about it. So yeah, I do hope my presentation was good. See ya. Bye.